Welcome to Presidency Senior Secondary School online class. Today we will take new topics of solution chapter, and that new topic is ideal and non-ideal solution. Ideal and non-ideal solution. So ideal non-ideal solution is applicable for binary liquid solution. So both these terms are applicable for binary liquid solution. So ideal and non-ideal solution term is used to explain binary liquid solution. Binary means two component and both are liquid. So first we consider ideal solution. So ideal solution means binary solution, that is, we have two components present. So this is one component which is liquid, say A, and this is another component, say B. Both are liquid. So it is liquid. And two components, so binary solution. Okay. Now these two are mixed together. Then we get solution where both A and B are present. So to explain ideal solution, here we consider two liquids, one A, another B. Since two liquids we have taken, so it is binary and they are mixed together, so we get solution where both A and B are present. Now these two components A and B will form ideal solution only if their molecular size similar, molecular mass similar, structure similar, intermolecular force similar. So when two components A and B form ideal solution, then their molecular mass almost same. Number two, similar structure. Number three, similar intermolecular forces. So two components form ideal solution only if their molecular mass similar or almost same, their structure almost same or similar, and similar intermolecular forces. If two components possess both all of these characteristics, then they can form ideal solution. So ideal liquid solution formation requires three prerequisites. Number one, their molecular mass almost same or similar, their structure similar, and finally intermolecular forces are also similar. So if two components form ideal solution, then these are three preconditions for formation of ideal solution. Now if we take example of such solution, number 1, benzene and toluene. So this is structure of benzene and this is structure of toluene. So molecular mass similar, similar structure and similar intermolecular forces. So benzene when mixed with toluene, so if one of them is benzene, other will say toluene, then when they are mixed together, then they can form ideal solution. Second example, N-hexane and N-heptane. N-hexane and N-heptane. N-hexane where C6H14 and here C7H16. Almost similar straight chain structure. So they can also form ideal solution. Third, bromoethane and iodoethane. Third example. Bromoethane and iodoethane. Fourth example, chlorobenzene and bromobenzene. What is structure of chlorobenzene? So this is structure of chlorobenzene and this is structure of bromobenzene. So these are 4 important examples of ideal solution. So 2 liquids form ideal solution if their structures are similar, molecular mass similar or comparable molecular mass, and also similar intermolecular forces. So these are 4 examples where structure similar, molecular mass almost similar, and also possess similar intermolecular forces. Example, benzene and toluene form ideal solution. N-hexane and N-heptane also form ideal solution. Bromoethane and iodoethane form ideal solution, and also chlorobenzene and bromobenzene also form ideal solution. So these are 4 examples of ideal solution where they have similar structure, similar intermolecular forces, and also similar molecular masses. Next we consider in details ideal solution. So these are 4 examples of ideal solution. So next we consider in details ideal solution. Now for formation of ideal solution, there are 4 important characteristics of ideal solution. So characteristics of ideal solution. Number 1, both the components obey Raoult's law. Number 2, the interaction before mixing is equal to interaction after mixing. That is A and BB interaction is equal to AB interaction. Third one, there is no volume change on mixing. And finally, number 4, there is no enthalpy change on mixing. That is, del H mix is equal to 0. So these are 4 important characteristics of Raoult's law. Each component obeys Raoult's law, means PA equal to XA, PA naught, and PB equal to XB, PB naught, and also P equal to PA plus PB. It is total vapor pressure equal to sum of partial pressure. So first condition, both the components obeys Raoult's law. Second one, interaction before mixing. Say first liquid is A and second liquid is B, and after mixing we get a B. So before mixing A interaction and BB interaction, and after mixing AB interaction, or interaction possess similar intermolecular forces. Third one, there is no volume change on mixing. That is, if 5 ml of A mixed with 5 ml of B, then total volume before mixing equal to 10 ml, and after mixing also 10 ml. So there is no change in volume that is volume change on mixing is 0. And finally, enthalpy change on mixing is also 0. That is, process of mixing is neither endothermic nor exothermic. So these are 4 characteristics of ideal solution. So if we compare or if we consider 2 liquids, say one A and other B. So here A interaction and here BB interaction, and after mixing here both A and B are present, so here AB interaction. All interactions are of same magnitude. When they are mixed together, say this one is 5 ml and this one is 5 ml. So before mixing 10 ml, after mixing also 10 ml. So there is no change in volume. That is, del V of mixing is 0. And finally, when A mixed with B, there is no chance of liberating or absorbing heat. That is, enthalpy change on mixing is 0. And both these components obeys Raoult's law. So these are 4 important characteristics of ideal solution. Then what is ideal solution? Solution which obeys Raoult's law is known as ideal solution. One simple line, the solutions which are obeying Raoult's law are known as ideal solution. जो solution Raoult's law को मान के चलेंगे, such solution is called ideal solution. So for formation of ideal solution, their structure must be similar, molecular mass must be similar, and also intermolecular forces also similar. Next we consider non-ideal solution. So before non-ideal solution, first we consider graphical representation of ideal solution. So vapor pressure against mole fraction. So at this point, mole fraction of x equal to 1. So B must be 0. So that sum equal to 1. So which represent pure A. Here mole fraction of A equal to 0 and B equal to 1. So it represent pure B. Now we know that PA equal to XA PA naught. So when XA equal to 1, then PA equal to 1 into PA naught, that is PA naught. So when XA equal to 1, that is mole fraction of A equal to 1, it is pure A, then PA equal to, so vapor pressure is equal to PA naught. And vapor pressure and PB equal to XB to B naught. So here XB equal to 0. So vapor pressure also 0. So here PB naught equal to 0. So this way. Now at this point, PA equal to XA PA naught. So XA equal to 0. Equal to 0. So this is value of PA naught, which is 0. Now PB equal to, here XB PB naught, XB equal to 1. So PB naught, maximum value. So this point represent pure A and this point represent pure B. As we move from this point to this point, value of mole fraction decreases from 1 to 0. It is between these 2 points, mole fraction of A, all fractional values, because this one 1 and this one 0. So between 1 and 0, it is all fractional values, and here also this one is 0 and this one is 1. So in between all fractional values, it is in between these 2 points represent solution. So this is for PA, this is for PB, and this one represent P, that is PA plus PB. So this is graphical representation of ideal solution. So next we consider non-ideal solution. So what is ideal solution? Solution which obeys Raoult's law is known as ideal solution. What is non-ideal solution? The solutions which do not obey ideal Raoult's law is known as non-ideal solution. So what is ideal solution? If any solution obeys Raoult's law is known as ideal solution. If any solution disobeys Raoult's law is known as non-ideal. So ideal obeys Raoult's law. Non-ideal disobeys Raoult's law. So there are again 4 different characteristics of ideal solution. So ideal solution disobeys Raoult's, non-ideal solution disobeys Raoult's law. So next we consider of non-ideal solution. So first point of non-ideal solution is their components do not obey Raoult's law. That is, PA is not equal to except PA naught and PB not equal to XB PB naught. So this is first point of non-ideal solution. Second one, here the interaction before mixing AA and BB is different from interaction after mixing. It is every interaction. Third point is volume change on mixing is not equal to 0. It is LB mix is not equal to 0, and finally there is enthalpy change on mixing. There is enthalpy change in on mixing, that is del H mix equal to 0. Mix is not equal to 0. So these are 4 characteristics of non-ideal solution. So first one is their component do not obey Raoult's law. That is, here Pa is not equal to XA Pa naught and Pb not equal to XB Pb naught. Second point, the interaction before mixing, it is A and Bb interaction, are different from interaction after mixing, that is AB interaction. Number 3, volume change on mixing is not equal to 0. That is, there may be increase in volume, may be decrease in volume, but not equal to 0. That is, volume change on mixing, increasing means positive, decreasing means negative. That is, there is some change in volume after mixing. Maybe increasing, maybe decreasing. If increasing, then it is positive. If decreasing, then negative. And last point, enthalpy change on mixing is not equal to 0. That is, there is some enthalpy change. It may be endothermic, that is absorbing, or it may be exothermic, that is heat evolving. So these are 4 characteristics of non-ideal solution. First one, their components do not obey Raoult's law. Second one, interaction before mixing is not equal to interaction after mixing. Third one, the volume change on mixing is not equal to 0. And finally, there is enthalpy change on mixing. That is, enthalpy change on mixing is also not equal to 0. It may be endothermic, it may be exothermic. Next, we will consider difference between ideal and non-ideal solution. So there are different points are available to distinguish ideal and non-ideal solution. So first one, each component obeys Raoult's law. that is PA equal to XA, PA naught, and PB equal to XB, PB naught. So this is first point. Here their components do not obey Brown's law. That is PA not equal to XA, PA naught, and PB not equal to XB, PB naught. So this is first point of difference. Second point, there is no enthalpy change on mixing. That is del H mix is equal to 0. Here there is enthalpy change on mixing. That is del H mix is not equal to 0. Third point, there is no volume change on mixing. That is del V mix equal to 0. Here there is volume change on mixing. That is del V mix is also not equal to 0. And finally, interaction before mixing is equal to interaction after mixing. Here in case of non-ideal solution, interaction before mixing AA and BB interaction is not equal to interaction after mixing. That is AB interaction. So these are 4 points of difference between ideal and non-ideal solution. First point, each component obeys Raoult's law. Second, none of them obeys Raoult's law. Disobeys Raoult's law, or do not obey Raoult's law. In case of ideal solution, there is no enthalpy change on mixing. In case of non-ideal solution, there is enthalpy change in mixing. That is, enthalpy change on mixing is not equal to 0. Third point, there is no volume change on mixing. That is, del V mix is equal to 0. There is no volume change, but there is some volume change. Maybe increasing, maybe decreasing, maybe positive, maybe negative. And finally, interaction before mixing is here equal to interaction after mixing. But in case of non-ideal solution, interaction before mixing is not equal to interaction after mixing. That is, maybe less interaction after mixing, maybe more interaction. So depending on nature of interaction, non-ideal solution again classified into two types. So first of all, note these points. So these are 4 points of difference between ideal and non-ideal solution. Now, in our next topics, we consider only non-ideal solution. Next, we consider only non-ideal solution. Because depending upon nature of interaction, whether interaction before mixing is more or less than interaction after mixing, non-ideal solutions are further classified into two types. Number one, non-ideal solution showing positive deviation from Raoult's law. Non-ideal solution showing positive deviation from Raoult's law. And next one, non-ideal solution showing negative deviation from Raoult's law. So non-ideal solutions are again of two types. Number one, non-ideal solution showing positive deviation from Raoult's law, and number two, non-ideal solution showing negative deviation from Raoult's law. So in next lecture, I will consider types of non-ideal solution. That is, non-ideal solution showing positive deviation from Raoult's law, and also non-ideal solution where negative deviation from Raoult's law. Okay, thank you.